In this video, we'll see for the first time a method that can be used to help us solve physics problems. It's called the GUESS method. GUESS is an acronym developed by Dr. John Scott, my former colleague. G stands for given, the variables that we are given in the problem statement. U stands for unknown, which is the variable that we're looking for. E stands for equation, which is typically a physics equation that often appears on an equation sheet. The equations for this unit of study that I allow my students to use are shown here. We've already met average speed is distance over time, or if you want to change those into vectors, you could say average velocity is displacement over time. Those are also equal to this thing here, but we'll deal with that another day. Recently, in a video, we've met acceleration, which is change in velocity over change in time. And later on, we will add two more equations, and we will start to do some problems in free fall, where the acceleration due to Earth's gravity is 9.81 meters per second squared. But that's a story for another day. The first S in the acronym GUESS stands for solve the equation for the unknown variable. Whatever variable we're looking for, we need to algebraically manipulate the equation such that that variable is the only one on the left side of the equation. And only last do we substitute numbers in. Let's show you how this works. An arrow is accelerated by a bowstring to 36 meters per second in 0.31 seconds. Find the arrow's acceleration. Let's start with the givens. That looks like a time to me. So we'll write that down. It's accelerated by a bowstring to this. That's an important word there. It didn't start out at 36 meters per second. It ended at 36 meters per second. So that is our final speed. Our initial speed is kind of hidden in there. It's 0. This arrow is going to start from rest and is going to be accelerated by that bowstring. The unknown is the acceleration. We need to look through our equations now and find one that is going to help us get to where we need to go. And that's going to be the one here in the lower left corner. Acceleration is change in velocity over time, which is also v final minus v initial divided by time. So that's the equation I'm going to write here. In fact, this middle part of the equation, I don't think I'm going to use that, because what I have is v final, v initial, time, and I'm looking for the acceleration. So this first S, which stands for solve the equation for the variable you're looking for, we don't need to do any work there. The equation is already solved for the variable we're looking for. The last step, substitute numbers in. So let's do that. V final is 36 minus 0. I'm going to go ahead and put the units in there, even though we checked them at the beginning. We're going to want to round this to 2 significant figures, because that is the number of significant figures that we have in our given variables. So to 2 significant figures, my calculator says this comes out to be 120. And you can see that the unit for acceleration is right there in the work. Meters per second, sometimes shortened to meters per second squared. Let's try another one. Here we have a car traveling 65 meters per second, and it approaches a stop sign. The driver applies the brakes for 8.2 seconds. Find the car's acceleration. We start off with the car already moving at 65 meters per second. That looks like an initial velocity, which incidentally, 65 meters per second is very fast for a car. It approaches a stop sign. The driver applies the brakes for 8.2 seconds. So clearly that is a time. We're looking for the car's acceleration. So that is the unknown variable. Are there any other variables that we know? And the answer is yes. This is a stop sign. We are going to assume, as should be done at all stop signs, that our final speed is going to be 0. The equation we're going to use is going to be the same one that we used last time. Acceleration is change in velocity over time, which is v final minus v initial divided by time. Anytime you see this delta sign in science, it always means final minus initial. We're looking for acceleration. We have the final velocity, we have the initial velocity, we have the time. So once again, I think I'm not going to use that middle part of the equation. And once again, we don't need to do any work in that first S, which stands for solve the equation for the variable we're looking for. So now we're just going to plug in the numbers. And the acceleration is going to be v final, which is 0, minus v initial. Again, I'll put the units in there. And we're going to divide by 8.2 seconds. And when we type this into our calculator, we get a rather interesting number. To two significant figures, negative 7.9 meters per second squared. And we might wonder why it came out negative. And the answer is, in an earlier video, we talked about how if the sign of velocity and acceleration is opposite, then the object is going to be slowing down. And you can see right here where I'm pointing with my marker, we chose the initial velocity to be positive. We maybe didn't think about it, but we did. And clearly this object is going to be slowing down, so hopefully it shouldn't be too much of a surprise that our acceleration turns out negative.